Welcome to question 11. Consider the quadratic equation 2px squared plus bracket p minus 1 close bracket x plus 2p equals 0. Calculate the discriminant. So first things first, get our discriminant equation going again. B squared minus 4ac. In this case, b is equal to this. A is equal to 2p and C is also equal to 2p. So our discriminant is going to be equal to p minus 1 squared minus 4 times 2p times 2p, which means that if we simplify that all down, so that's minus 16p squared. And then we have p minus 1 squared. And then that will become p squared minus 2p p plus 1 minus 16p squared. So the discriminant is equal to negative 15p squared minus 2p plus 1. All right, and from here, we now need to take this and use it in different scenarios. So find the values for p for which there is only a single solution. Remember that if the discriminant is equal to 0, then there's only one solution. If the discriminant is equal to 0, then one solution. That means it's 0 equals negative 15p squared minus 2p plus 1, which means we need to use the quadratic formula on that to get the answer that we need. All right, so find the values of p for which there is one solution. We're going to have multiple values. It's going to be a range. So we need to now solve for p. So in this case, p is going to be equal to plus 2 plus minus the square root of 4 minus 4 times minus 15 plus 1, all divided by minus 2a, which is minus 30. So p is going to be equal to 2 plus minus, now minus 4 times minus 15 is plus 60, times 1 is 60 still, so it's 60 plus 4, so it's going to be 64, which happens to be equal to 8, which makes our life a little bit easier, minus 30. So therefore, p is going to be equal to 2 plus minus 8 over 30. So in this case, p is going to be equal to 10 over minus 30, or minus 6 over minus 30. So it's going to be equal, so p is going to be negative a third or a fifth. All right. Now that we have that, that makes things a little bit easier. Now, what we can do from here is recognize that if it is exactly this or exactly this, there is one solution. But what about if we were to pick a point that is between these 2 points? So in this case here, 0. 0 happens to be between these 2 points. And let's just try that in our discriminant equation. Our discriminant equation, so we'll try p equals 0 in our discriminant equation. So that's going to therefore mean that triangle is equal to 1. Because triangle is equal to 1 when it's between these two numbers, and remember that if it has two solutions, then it's going to be, the discriminant is going to be equal to more than 0. If I then think about what's outside these two numbers here, like for example, 1 or -1, I can use logic to simply say, well, okay, it's something that's either between these two or everything but those two, to help me narrow down how to find these answers without doing any more math work. I say any math work, I mean a lot less math work. So if we try p equals -1, -1 squared is just 1, so it's 15, so it's -15 plus 2 plus 1, so it's -12. Triangle equals -12. And if we try p equals 1, 15 minus 2 plus 1 is -16. Therefore, what we can know is that if p is greater than 1/5 or less than 1/3, discriminant equals 0. Well, discriminant is less than 0, no solutions. But if p is between these two values, the discriminant is more than 0, therefore we have two solutions. This was probably the hardest question on the SAT. All right? But if you work through it logically, it makes your life a little bit easier. See you for the last question.